I'm getting creative with how to include the candy corn jar in the shots. Okay, so in this video, we are going to be creating a binomial PDF based off of the proportion that we decided upon, that by we, I mean me, decided upon in the last video. So again, the real number of candy corns is 343, and what we found was that not about, exactly, because this was, well, I did round, so about 29.55% of you guessed within 100 candy corns of that real value. So what we're going to be doing now is kind of generalize this to other samples. If I were to go sample other groups, other people, what would we expect to happen? What would we guess to happen? So I'm going to go ahead and start. I'm going to open a new sheet here, and I'm going to rename this to call it binomial distribution. Okay. And again, our proportion, which is the 0.2955, the number of you that guessed between 243 and 443. Oh yeah, I forgot. As a reminder, I told you in another video, if you paste formulas from one place to another, it won't paste correctly if you're wanting that value. So I'm going to come in here and instead of doing Control V or right clicking and just doing paste like normal, if you do this one, it pastes the actual value, not the formula. So I'm going to do that and then reround it here. Okay, so this is that proportion that we're looking at. What we're going to do is in our binomial experiment, and I'm going to zoom in here so that you can see what I'm typing. We are going to be letting X be the number of people who guess within 100 of the right number of candy corns. So this is the proportion that we had from our data set. So the way you can think about this is that this is the probability of success. So we're saying the probability that I randomly select someone from our data set, for example, who guessed between 100 or within 100 of the right number, this would be the probability of success. So let's then find the probability of failure. So again, the probability of failure is the complement of the probability of success. So in this case, if the probability that one person guesses within 100 is this number, then the probability that someone guesses not within 100 would be 1 minus, because again, the proportion of success and failure, or the probability of success and the probability of failure, needs to add up to 1 or 100%. Because that needs to take up like the entire sample space. We can't have anything falling outside of these events happening. Okay, so we can type equals 1 minus, and then I'm going to click on this number. So the reason why I'm clicking and not typing, because I could type here, but when you click on this cell, it's taking that exact value. What we see is a rounded number, but when Excel is calculating this, it's actually using the exact value that's written there, not just that number. So when I type enter here, this is really, if I were to add, look at, this is an exact value as well. So that's why I'm clicking on that instead. Okay, so we have the number of people who guess within 100 of the right number, that probability from our data set, which we are going to be using as a probability of success, was 0.2955, and the probability of failure then would be 0.7045. As a percent, I want to reiterate what that means. That means about 70% of you guessed outside of that range. So 70% of you guessed over 100 away from the correct number of candy corns. So that's about, again, a third, between whatever, I'll round, about a third of you guessed within, and 2/3 of you guessed outside of that range. Okay. So what we're going to do with our binomial experiment is we're going to look at a certain number of trials. So I'm like designing a binomial experiment. So the number of trials I'm going to look at, I'm going to say that we go and survey 20 people. So I'm going to go survey 20 people at the Stater Brothers Market down the street. Or I'm going to go survey people at Starbucks near campus. Who knows? Okay. So the number of trials, that means like each person. So in this case, a trial is one person. So I'm asking, I'm asking this person to guess the number of candy corns here, and then I'm evaluating, are they within 100 or not? But again, I'm doing this like in groups of 20. All right. So a trial is one person guessing. I should maybe write that. One person guessing. A success is guessing within 100. A failure is guessing over 100 away. And so what we're counting here is again where that probability of success is kind of associated there. Okay. So far with the binomial experiment, we have a fixed number of trials, which is required. So I'm saying we're surveying 20 people. That's it. I'm not saying we're surveying people until we get 30 people that guess within 100. That would be like, there could be a lot of trials for that. We're just looking at 20 people. That's it. Fixed number of trials. We have a probability of success. We have a probability of failure. Now, I want to add an asterisk to our experiment that when we ask people, we do not ask people in front of other people guessing. So I'm adding this to make sure that our trials are independent. Now, this is also the same reason that in our discussion board, when you made your guesses, I made it to where you couldn't see what other people were guessing before you made your own guess. Because if you saw what other people were guessing, chances are it would influence what you guess. So in that case, the trials wouldn't be independent because the probability of what you're guessing changes depending on what you've seen. So in that case, it would be a dependent situation. So here we're assuming that I'm asking people who can't hear what other guesses are. This is a completely individual guess. There's no influence from other people, other people making guesses. Okay, so we have independent trials. There's 20 trials. We have a probability of success, which stays the same from trial to trial. Again, we're assuming the probability that someone guesses within 100 is about 0.2955. So I'll go over this again. So we have a set number of trials, a fixed number of trials. The trials are independent because people aren't listening to what other people are guessing. And then we're assuming that the probability someone guesses within 100 is about 0.2955, and we're assuming that stays the same from person to person. The probability of success and the probability of failure have to add up to 1, which if you remember, that's how we actually found the probability of failure. So when we add these, we should get 1, which we do. That's really good news. Okay. So here we have a binomial experiment. We also have only a success, only a failure. Okay. So now that we have this binomial experiment, what we're going to do is create the PDF for this binomial experiment, but that's going to be in the next video. So I'm going to kind of keep these shorter. So this video is explaining how are we setting up this to be a binomial distribution experiment so that we've met these criteria that we've talked about in our class. And then the next video, we're going to actually set up that PDF table so that we can really look at these the data and that distribution. So catch you in the next one.